All right, average value word problems. Now we're just going to take the exact same formula that we used in the previous video and just apply them to word problems. So how do you spot these word problems? Well, they got the word average in them. Pretty much has to have the word average or it's not one of these. And that's kind of great. Also, you know, usually you'll be on the chapter test that has average value problems on it. So you'll kind of know that any word problem you see is likely to be of this type. But then also if you're on the final or something, that average value thing, in this case average account balance, but just the average anything, you really want to be thinking, that's probably one of these. So let's take a crack. So in this case we got a bank account that's growing continuously. And that word continuously is important because that means we're going to use the PERT equation. Just account is like interest compounded continuously equals, it's the amount in the account, or the balance, equals P times e to the RT, where P is principal, what we're starting with. So in this case, P is 500. Then we got E, and then the interest rate is 0.15. And T is time. So we'll just leave that as T. Alright, so if we want to find the average balance, we need to integrate this. And just to remind you, 1 over b minus a, integral from a to b of the function dx. Now of course x's can be t's or whatever, just as long as these two letters match, that's fine. So we're going to do 1 over, and then this is going from 0 to 5, because we want to know over the first 5 years. So 5 minus 0 of 500 times e to the 0.15t dt. Alright, so you notice I left myself a little bit of room in here, and that's because I'm going to have to stick some stuff in. So first of all, what is my u? Well, since we've got an exponential e to the something, my u is just going to be that exponent, which is 0.15t, which means my du is 0.15 dt, and that means I need a 0.15 right here. So right away, I got to divide by a 0.15. Looks good. I think we're ready to go. So the integral, this is really just the integral of e to the u, so same thing, right? By now you're getting used to that. So if I take all my constants and lump them together into one fraction, I'll get 500 in the numerator, because that's right there. Now I've got a 5 and a 0.15 downstairs. And then I've got the integral of e to the 0.15t is just e to the 0.15t, evaluated from 0 to 5. Now this is pretty tough to type in your calculator. The main thing you need, obviously it's just a mess, but the thing to know is if you want to type in the exponent of e. So for example, when I plug in 5, I'm going to get, so this will be 500, 5 times 0.15 is 0.75. And then, so that's my coefficient, but then inside I'm going to have e to the 0.15 times 5, which is 0.75, so I'll just write that down. And then subtracting, and now I'm going to plug in 0, and I'll just get e to the 0. Alright, so the question is, e to the 0 is just 1, so that's cool. The question is, how do you get e to the 0.75? What you do is you type in second. So the second button, if you look at natural log, right above the natural log button is an e to the x button, or an e to the x is written right there. The way you get that is second, so you hit second and then natural log, and that'll give you an e, and then they'll put a little caret and parenthesis. So that means we're now typing in the exponent of e. So you can plug in 0.75, close the parenthesis, and that'll give you e to the 0.75. Then of course subtract 1 from that, hit enter, then multiply by 500 over 0.75. After you do all that, I think you get $610. I typed it in several times just to be sure. I got 610. Alright, so the average value of this account over that time is $610. Now keep in mind that is not the final value of the 5 years. So like if you're back in Algebra 2, what they would want you to tell them is, hey, what's the final balance? They'd want to say, hey, if we put $500 in an account and we earn 15% per year, how much do we have at the end of 5 years? Because that's what someone really care about, right? You care about, hey, if I put my money away for 5 years, how much will I end up with? You don't really care about the average value. So that's what Algebra 2 is all about, was just plugging in 5 years to this PERT equation. But if you look at the graph of this thing, it's growing exponentially, so it starts at 500 and then kind of does this sort of thing. What we just calculated was somewhere along here, sort of the average value of that time. So the average value would be more than you started with, but less than you ended up with, and that's how we get $610. the final value, we'd have to plug in 5 to this equation, and that's not really a calculus problem. That's an algebra 2 problem, or pre-calc or something. But the point is it's going to be more than $610. All we did was just find the value right here, this average value that's sort of halfway between the beginning and the end. All right, water leaking out of a tank. This might initially sound like it might be a related rates derivatives problem, right? Because anytime you talk about rates or leaks or water going places, usually it's related rates. But what is the key word we're looking for? Average leak rate. And also, you'll notice they're not asking the rate at which something happens. They're not saying how fast is the water level rising, like you would in related rates. They're not asking, the questions they're asking are not what are the rates of things, they're using the word average. So a related rates problem will say, hey, what's the rate of the leak at time equals 5? Or how fast is the height going up? Whatever. They'll ask about a specific point in time. But as soon as you got the average, we now are talking about integrals. And just to be to make it a little bit simpler, I said, hey, how much water comes out in 3 hours? So for the first question we'll ask is, how much water comes out in 3 hours? Well, to get the amount of water that comes out in 3 hours, we're just going to take the integral from 0 to 3 of the leak rate. So if you integrate the leak rate, you'll get the total amount that leaks. So the integral of 2 over t plus 1 dt. Let's see, so u equals t plus 1, which means that du equals dt. And we already have that. So this is simply going to be, I'll move the 2 out front. So that's 2 times the natural log of u, which is t plus 1. And we need to evaluate that from 0 to 3. Alright, so when I type that in a calculator, I got 2.77 liters. So that's in the first 3 hours. But now, what is the average leak rate? Well, so the leak started out faster, but then as time goes on, this denominator gets bigger and it's leaking slower and slower. So the water cooler is coming out slower and slower over time. The average rate is going to be the amount that leaked out in 3 hours divided by 3 hours. Because you'll notice that in our equation for average, it's just 1 over b minus a times the integral from 0 to 3 of the function. But isn't this what we just found? So this is 2.77 liters, which means all we need, sorry, this is really a and b. So really we just need 1/3 times the answer we just found. So that's going to equal 0.923. And then what are the units of that? Well, it's liters, because that was the liters. And then the unit is hours, unit of time. So there you go. So if something's coming out or a rate's happening, if there's a leak, if something's filling up, the total amount that came in is going to be the integral, the definite integral over the time span. But then if you want to find the average, you just got to divide by the amount of time that things were happening. All right, driving, similar story. So a sleepy driver, I'm basically imagining someone driving someplace on a road trip and they're sort of like start to lull off and then they slow down because their foot kind of eases off the gas, and then they wake up and they want to get home fast so they don't fall asleep again, so then they hammer it. So what ends up happening is they're just going faster and slower and faster and slower. And who knows where I got this equation right? I just cooked this up. But the point is, all these word problems do is they come up with some kind of silly scenario that allows them to write down a function. And then you just want to know average speed, right? So what's the average? So all you need to see is the word average, and then bingo, you're plugging in the equation. So 1 over b minus a times integral from a to b of the function dt. So in this case, we've got speed over 10 minutes. So we're integrating from 0 to 10, which means the coefficient out front is 1 over 10. And then we need the function. Again, I don't know where we got this function. Well, I do because I made it up. But the point is, it doesn't matter what crazy function they give you. Just integrate it, plug and chug through the average formula, and you'll be set. So that is going to equal 1/10. Now both of these are, this is all integratable. There's no u sub required. So it's going to be 1/10 times 60t minus 25. That's an ugly 5. 25 cosine t. And we've got to evaluate that from 0 to 10. So what do we get? So 1/10 times 60 times 10, so 600, minus 25 cosine of 10, minus, and then when we plug in 0, we're just going to get 60 times 0 is 0, 20, but then minus 25, because the cosine of 0 is 1, so that's why we get that. But then we end up adding the 25. So we plug and chug that through a calculator, and I got 64.9. So how do we get an average value? If this guy's just speeding up and slowing down, why didn't we just get an average value that was 60? Well, it just depends on how many times we went up and down. This one was set up so that in 10 minutes we went from up to down to up again. So the area we were covering there was more above the x-axis than below. So that's why our average value was actually skewed a little bit above 60. Really key point here. Whenever you're plugging in angles in calculus, it's almost always in radians. So when we had cosine of t here, your calculator has to be in radian mode when you plug in 10. Otherwise, you'll get a different answer than I got. You'll probably get something really close to 60 if you used degrees instead of radians. All right, over 50 minutes, we do the exact same calculation, except now we're integrating from 0 to 50, which means we have a 1 over 50 out front. But it's the same stuff, 60 plus 25 sine t. And I'll spare you the math, but I got 59 when I did it that way. So why is this time closer to 60? Well, if we take a long time span of 50 minutes, and this thing's going up and down every, looks like 2 pi minutes, which is like 6 minutes. So basically this guy's speeding up and slowing down cycle. He goes fast and then slow every 6 minutes. So if you do a short time period, like 10 minutes, then you're only going to catch one hump or maybe 2 humps if you're lucky. But then from 0 to 50 minutes, you're just going to get a lot more ups and downs. So sort of the law of averages is going to take over, and we'll expect an average way closer to 60 because there will be a more even number of highs and lows. So, all right, video views. Once again, we pretty much have an exponential growth problem. Now, right when you look at this problem, you want to get in the habit of, did they give me a function? And sure enough, there's a function right here. So what do you bet? We're just going to take the average value and integrate it over a week or over a time span. So what is my time span? Well, let's see. And after 2 days, you notice that the view count seems to be growing exponentially, views on YouTube or whatever. How many views will I have after a week? All right, so we're integrating for 7 days. Now I'm going to assume that this t is in days because after 2 days. So that kind of tells me that the unit of time in this problem is days, not weeks or hours or seconds or anything else. So we're going from 0 to 7, which means I got a 7 minus 0 downstairs here. And I just need to integrate 24 times e to the 1.2 t dt. All right, so let's see. My u is going to be 1.2 t, which means that du is 1.2 dt. So that means I need a 1.2 right here to make my dt work out, which means I got to divide by 1.2 to make up for it. All right, so now I've got a mess. I've got 24 over 1.2 times 7, which is just 24 over 8.4. And then the integral of e to the 1.2t is just e to the 1.2t, and that's from 0 to 7. All right, so you're obviously going to need a calculator to evaluate this. When I did that, I got 35,000. Actually, I got 5,000 views. Views per day. So do you see what I did? So that was the average rate, right? So our average is just, hey, you plug and chug through the average equation, you get this. But then so basically I answered part B first because I was so in like my mindless plug and chug through an average problem that I just plugged and chugged through the average and found the average right away. But then what's this first part of the problem? How many views will a view have after a week? Well, that's just the area under the curve. That's this exact same integral if we had just not put the 7 downstairs. So if you figure you average 5,081 views a day, and you want to know how many views you'll have after a week, that's just going to be 7 days times the 5,081. And after that, we get a 35,600 views in a week. All right, so if you have the average and you want to know what that adds up to over a certain period of time, just multiply by the time period, which is really just getting rid of that 1 over b minus a. Remember, the 1 over b minus a that we put in front of the integral, that's what turns our total into an average. So if you want to get from average to total, you just got to multiply by b minus a. All right, so that is word problems in a nutshell. As you can see, the word average is always going to show up, so that's key, and that's what's going to allow you to spot these. Other than that, it's always the same formula. It's always plug and chug. Not too bad.